Okay, good afternoon to all. Hello, Meghana.
Good afternoon, sir.
Good afternoon, sir.
Okay, good afternoon. Is it audible now?
Yes, sir.
Okay. Is it visible the screen?
Yes, sir.
Okay, ma'am. So I'll start the GATE classes for the subject of electromagnetics or electrostatics. Okay. In that electrostatics, we are having different types of topics like Maxwell equations, transmission lines, waveguides, and propagations. Okay, these are the topics. The Maxwell equations defining in different ways. That is nothing but now we'll see the Maxwell equations defining based on different ways. Okay, that is the time varying fields, and then static field and time varying field with free space. Time varying field in free space. Okay, these are the three different ways while defining the Maxwell equations. Okay, now in this Maxwell equations for the time varying field, here it is time varying field and static field. Here we can consider with respect to the time. Okay, time varying fields. Okay, now in this, now we'll consider the first one, Maxwell equations. Maxwell equations for time varying fields. Time varying fields. Now here in this one, again this time varying field we can defining in differential form and integrals forms. Differential form and integral form. And integral form. In this differential form, we can defining the Maxwell equations based on the cross product and scalar product, dot product. Okay, cross product and dot product. In the dot product, again del dot dv is equals to del dot d is equals to rho into v, and the second one is in terms of dot product lemma, del dot b is equals to 0. Okay, and in the case of cross product, del cross e is equals to minus dou e by dou t. Okay, and fourth one is del cross h is equals to j plus dou d by dou t. Okay, these are the four Maxwell equations defining based on the different amperes, Gauss law, and current laws in differential forms. Okay, first one is del dot d is equals to 0, where d is equal to electrostatic
Sir,
density. Yes.
sir,
చెప్పండి.
sir, అది minus dou b కదా సార్ అది
ఏది సెకండ్ వన్
dou b by dou t కదా సార్ అవును
Del
థర్డ్ వన్ సార్
yeah, del cross E is equals to minus dou B by dou T. Okay, minus, sorry for the disturbance. Okay, so del dot D is equals to rho V, where D is equal to electrostatic density and rho V is the volume integrals. Okay, whereas del dot B is equals to 0, that is the magnetic field density is equals to 0 dot product. Whereas in the cross product, del cross E is equals to minus dou B by dou T, that is, this is nothing but the relation between the electrostatic and electromagnetic intensity. Okay, whereas del cross H is equal to J plus dou D by dou T. These four equations are in the Maxwell equations for the time varying field in differential forms, whereas the corresponding integral forms. Okay, integral forms is integral of d into d of s is equals to integral of rho v into d of v. Okay, and the second one, integral of b into d of s is equals to 0, and third one, del cross e, integrals of e into d of l is equals to minus dou by dou t into integrals of b into d of s, and fourth one is integrals of h into d of l is equals to integrals of surface integrals. Okay, j plus dou d by dou t into d of s. Okay, these are all surface integrals and with respect to s squares. Okay, surface integrals. Okay, this is volume integrals, this is surface integrals. Okay, now see the first equation. This is the delta D is equals to rho V is the Maxwell equations for the time varying field in differential form, and the corresponding integral form is integral of D into D of S is equals to integral of rho V into dV. This equation we can call it as a Gauss law of electrostatic. Okay, Gauss law of electrostatic. And see the second equation, del dot B is equals to 0. Okay, dot product of magneto density is equals to 0, and the corresponding integral form, integral of B into D of S is equals to 0. This is call it as Gauss law of magnetostatics. That is the magnetic field. Okay, magnetostatics. Now see the third one, del cross E is equals to minus dou B by dou T. Okay, that is the electrostatic intensity curl product. Del cross E is equals to magnetic field density dou B, rate of changes of magnetic field density, that is dou B by dou T. Whereas in terms of integral form, integral of E into D of L is equals to minus dou by dou T into integrals of B into D of S. This equation we can call it as a Faraday's laws, Faraday's law of electromagnetic induction. Okay, because of it consists of for both electric fields, electric and magnetic. ఇక్కడ magnetic field density B, ఇక్కడ electric field, so రెండు relation ఉంది కాబట్టి then that is the Faraday's laws of electromagnetic inductions. Now see the last one, integral del cross H is equals to J plus dou D by dou T. Okay, this is nothing but Ampere's circuit law. Ampere's circuit law. Maxwell equations I can go for Maxwell equations on static fields. So any doubts in this one?
No,
So, simultaneously note down these equations also. Okay. Next, Maxwell equations for static field that is and integral form. First equation del cross is as corresponding integral of d of L is equal to 0. Is time varying with respect to time. It can vary.
Hello, sir.
Hello, hello.
Yes, sir.
అదే నెట్ డిస్కనెక్ట్ అయిందమ్మా షేరింగ్ స్క్రీన్. So is it visible the screen?
Yes, sir.
Okay. Okay. So Maxwell equations of time varying fields, static field, time varying field in free space. So Maxwell equations for time varying fields is again defining in different ways like differential forms and integral forms. In the differential form, I can recall all the equations. So del dot D is equals to rho V and del dot B is equals to 0 and del cross E is equals to minus dou B by dou T and del cross H is equals to J plus dou D by dou T. Whereas in the integral form, integrals of D into the corresponding integral form of the differential form equations. Okay, just I can adding the integrations on both sides. Okay, so both sides integration is now integral of del dot D is equals to del integral of, so taking the integrations on both sides for this equation. So integral of d into d of s, that is the surface integrals, is equals to integral of rho v into d of v. This equation we can call it as a Gauss law. Okay, now this del dot b is equals to 0, that is nothing but a differential forms. Okay, for this differential form, while representing in terms of integral form, you can take in the integrations on both sides. That is integral of b into d of s is equals to 0. Okay, now del cross E is equals to minus dou B by dou T. That is the electric field in terms of magnetic field density. Okay, that's why this electric field and magnetic field are related by defining the Faraday's laws of electromagnetic inductions. Okay, that's why this equation we call it as a Faraday's laws of electromagnetic induction. That is integral of E into d of s is equals to minus rho by dou t integral of b into d of s. And last one is integral of h is equal to a plus rho by dou t. That is nothing but magnetic intensity time in terms of current J. Terms of integral of h into d of l is equals to integral of j plus dou d by dou d of s. This equation we call it as a Ampere circuit law. Now you can see all the equations delta is equals to t, and here also this is equals to 0 and del cross E is equals to minus dou b by dou t, that is rate of change of magnetic flux density minus dou b by dou t is rate of change of magnetic density, because you are defining with respect to time varying. Okay, that's why dou b by dou t values. Here also intensity current electrostatic density d by dot. Okay. Now, three equations were representing in terms of fields. Static representation 0. Okay, and this is equals to 0 because there is no rate changes. There is no time varying. Okay, see. Is it audible now? Hello, Meghana, is it audible now?
Yes, sir.
Okay. Next, third one is Maxwell equations. Maxwell equations for time varying field, time varying field in free space. In free space. Okay, time varying field in free space medium. Now, same thing, you can defining these equations in differential form and integral forms. First, del cross E is equals to minus dou B by dou T and corresponding integral form E into D of L is equals to dou integral E into D of S. This is nothing but loss of Pare's law. And second one is del cross H is equals to minus dou E by dou T. That is equal to integral of H D of is equals to integrals of dou into D of S. This is a base law. Del zero into D of S is equals to 0. This equation has law of Okay. Now, so these are the equations of time varying field of free space medium. Now, what is the difference between the free time varying field and time varying field in free space? See, almost all the equations are similar except the third equation. See the third equation, second and third. Okay, in the second equation, del cross H is equals to J plus dou D by dou T for the Maxwell equations of time varying field, whereas in the free space medium just del cross H is equal to minus dou D by dou T. And third equation for the time varying del dot D is equals to rho V, whereas in the free space medium del dot D is equals to 0. That is only the difference. And first del cross E and del dot B both are similar to the time varying fields. Okay, now come to the statements of this Maxwell equations. Now you can come to first equation del dot D is equals to rho V. That is nothing but this equation, this equation del dot D is equals to rho V, or integral of D into D of S is equal to integral of rho V into dV. This is nothing but the total electric flux, that is the total electric flux passing through any closed path, any closed surface in D of S అన్నాం. ఇక్కడ టోటల్ ఎందుకు తీసుకున్నట్టే ఇంటెగ్రల్ ఆఫ్, ఓకే, సర్ఫేస్ ఇంటెగ్రల్స్ ఇది విత్ క్లోజ్డ్ సర్ఫేస్. ఇంటెగ్రల్ ఆఫ్ d into d of s is equal to integral of rho v into d of v is nothing but the total electric flux passing through any closed surface is equals to the total charge of the volume enclosed by the surface. Okay, this is the meaning of word statement of Gauss law or Maxwell equations in integral forms. Okay, once again tell you the total electric flux passing through any closed surface is equals to the total charge in the volume enclosed by the closed surface. Okay, and second, del dot B is equals to 0. That is nothing but in the integral form, integral of B into D of S is equals to 0. That is nothing but the total or net magnetic flux from a closed surface is equals to 0. Okay, the total flux enclosed by the closed surface is equals to 0. That is nothing but Maxwell equations of Gauss law. Next, del cross E is equals to minus dou B by dou T. Okay, del cross E is equals to minus dou B by dou T, or integral of E into D of L is equals to integral of dou by dou D of integral of B into D of S. This is nothing but Faraday's laws of electromagnetic induction. That is nothing but the EMF, electromagnetic force around the closed path, is equals to magnitude negative of the negative. This is the negative. Okay, the total EMF around the closed path is equals to the negative of the surface integral because D of S, surface integral of a rate of change of magnetic flux density because of dou by dou T of B. Okay, rate of change of magnetic flux density bounded by the closed path. Okay, that is the meaning. The electromagnetic force, once again, I repeat you, the total electromagnetic force, that is the EMF, around the closed path is equals to negative of surface integral, negative of the surface integrals of rate of change of magnetic flux density, that is B, okay, over the surface bounded by the closed path is nothing but Faraday's laws of electromagnetic induction of Maxwell equation. Okay, and fourth one is del cross H is equal to J plus dou D by dou T. Okay, that is equal to J plus dou D by dou T. That is nothing but the magnetomotive force MMF. Here it is EMF, ఇక్కడ వచ్చేసి MMF, magnetomotive force. Okay, magnetomotive force MMF around the closed path, around this closed path, because of total integral of H into D of L. Closed path is equals to the surface integral of conduction current density J, conduction current density J, and displacement current density over the surface bounded by the closed path. Okay, the magnetomotive force around the closed path is equals to the surface integrals D of S, surface integrals of current density and displacement current density over the surface bounded by this closed path. That is nothing but Ampere's current law. Okay, so the MMF is related in current density and displacement current. Okay, next, boundary conditions of, now I will erase all these things. Okay, next, boundary conditions. Boundary conditions. Is it audible, Meghana?
Yes, sir.
Okay. Just 1 minute. Next, boundary conditions of electromagnetic fields. So boundary conditions, how we can define it? Boundary conditions. Boundary conditions. Okay. So far that discuss about the existence of electric field in homogeneous electric fields and magnetic fields in terms of Maxwell equations for time varying fields, static fields, and time varying field in space medium. Suppose the region is changes from one medium to another medium, like water medium to free space medium or free space medium to mediums or any medium. If we can consider the two regions or two different mediums, what is the conditions of fields satisfying the interfacing between the medium is boundary conditions. When the wave is traveling from one medium to another medium, okay, now it can satisfy or it can interfacing from one medium to other medium, then that is called boundary conditions. These conditions are helpful in determining the fields. On one side of the boundary, the field, the other side is that is nothing but dielectric and dielectric medium. Dielectric epsilon R1